welcome to the channel. In this video I'm going to show a couple of things that I feel are important to understand. One being wireless transfer, using a spark gap, using a fluorescent tube as a spark gap. The collectors here as well, the radiant energy collectors down there that I will demonstrate towards the end of this video. The small bulb in the center here is to demonstrate the importance of spark gap tuning and how you'll get nothing if it's not tuned properly. And then we'll also show this light here running to ground. This is a 240 volt 20 watt LED bulb. So we'll run that first of all through the gas inside the fluorescent tube, and then we'll also run it without the fluorescent tube in an attempt to demonstrate the wireless ability. And as far as I can think, that's about it. So we'll turn on the system. So we've got the plasma ball running, runs down through one wire into this coil. This coil here is of the Capacitor design, or Capacitor, a European designs from another device, but produces a strong radio field, so it would be good for demonstrating this. Okay, so out of plasma ball into the Capacitor coil, which I stuck a fluoro tube inside. If I earth that out with my hand, intensifies brightness. It also diminishes the output through the secondary coil. So here we have fluorescent tube. I'll disconnect this light in an attempt to display the gas lighting up inside. You can see it just at both ends. This end, the input end to the gas, is usually about 1 or 2 degrees lower than this end. I'm not really sure why. Now, it also feels like there's some sort of heat radiating from that part of the coil, but that's not what we're doing here, so we will leave that for another video. So if I connect that back up, we have that 240 volt light running to earth. Something with the CMOS sensor on these cameras, they tend to block out the intensity after it focuses. You put your hand over it and you'll see the true intensity when it refocuses. Okay, so that's running through the tube. If we disconnect that tube, that light goes out. It was actually running through the tube and through that incandescent bulb. So if we connect that directly to earth, it's trying to make a liar out of me now. move this over so it's wirelessly connected, and the light tries to turn on, but part of that is the fact that this coil is not tuned, it is not resonant with the other coil, but it does demonstrate that those particulars, you don't have to be 100% accurate. If you're going for efficiency, naturally, of course, you have to go for accuracy. So in other words, this coil here would need to be tuned and be the same resonant frequency as this coil, so that they operate harmoniously. So if we now disconnect this LED, which is running purely through wireless, there is no connection between those two coils. So that shows, you know, this is a 240 volt light with 20 watt normal consumption. But clearly it's not bright. Clearly it's not as running at optimal efficiency, but it is wireless. So that would be the drawback. If you had a perfectly resonant coil, it may get, well, it should be a lot brighter. So that's still wireless. It's still operating. Okay, so if we disconnect that, now I should move that out the way, and what I'll attempt to do is show you the importance of getting your spark gap correctly tuned. So if we connect that to there, and we take this other lead and we connect that to the other terminal. Not so easily done with one hand. We'll set that in a position where we can see, and I will try to get the spark gap correctly tuned here, and doing this by hand is crude. You obviously want more precision when doing this, but if we connect it directly, we can see that no light. So this should point out the importance or the role of the spark gap. Try and get spark gap and light in the same frame. Okay, so you can see if the spark gap is correct, the bulb will light. Obviously, there's a lot of inconsistencies with me doing it this way, but it's purely to demonstrate no spark gap, no light. Spark gap, and we get light. Okay, and apparently a bit of smoke. It's really difficult for me to achieve accuracy like this without killing myself. But I think I'll demonstrate there that get the spark gap correct. And you're going to get power from somewhere else. Okay, so that's pretty straightforward. Let's have a look at these radiant energy collectors. If we take that away, be careful not to touch anything that we shouldn't touch. And so we've got two collectors here, one with its own little aerial. Again, spark gap allows these to increase in intensity. If I angle that towards the camera and we place spark gap, so that's pretty obvious that increases intensity. Also, the fluorescent tube will light up brighter if there's a spark gap. So obviously the spark gap plays a role. Let's connect, so one of these collectors has its own aerial. If I touch that, it obviously earths out on me and produces more or collects more power. They're pretty straightforward. If you want the instructions on how I built these, because they are different. We've got that one there, it has its own aerial. This one here has two lights on it. Basically, this one doesn't have its own aerial, but has two lights in series, so it has to reach higher voltages for it to work. If I add the earth to it, we've now got this collector picking up that field, running it through to this collector, and obviously there's an intensity in voltage then and brightness, and then between these two LEDs, which are in series, this cable is now, this white cable runs to earth. So I think that's about it. If you need any more details or need any information on how these are wired up, you're interested, let me know in the comments and I'll do a specific video on those. They're not that different to collectors that other people have shown online, so but yeah, if you need information, let me know. Thanks again for watching. Please like and subscribe. Have a nice day.